Welcome to qnawire.
Okay, what is the relationship between R-cysteine and S-alanine? So what is the structure of R-cysteine? Okay, here's R-cysteine, and let's look at S-alanine. Okay, they look very similar, right? Literally the only difference is that instead of a hydrogen over here, we've got a thiol. Okay, but other than that, like in terms of their 3D configuration, right? They've got, if you orient them to have a similarly shaped backbone, the nitrogen's coming towards you, right? The amine is coming towards you in either case, right? Uh, so these have opposite stereochemical designation, but identical 3D stereo configuration. Right? And the reason for that is that when we determine whether this is R or S, if we look at the cysteine, we're looking at this carbon and we're looking at alpha carbon, we say nitrogen is the highest priority. Next, I've got to determine which of these two carbons is higher priority. The carbon on the right is bonded to sulfur as its highest priority bond, and the carbon on the left is bonded to an oxygen as its highest priority bond. So I compare the highest priority bonds that either one has, and sulfur has higher priority than oxygen. Therefore, this carbon has a higher priority, and this one has a lower one. Hydrogen's in the back, so I can determine R or S simply by connecting the dots and determining whether it's clockwise or counterclockwise. And here I get clockwise, so that's R. And if I do the same thing on alanine, right? Nitrogen is the highest priority, but now instead of this carbon being the second highest priority, it's this one, because we no longer have a bond to sulfur over here. We just have 3 bonds to hydrogen. So this is now the lowest priority carbon. And if I connect the priorities, it's counterclockwise, which is why we get S. Okay, so that's how we can end up with them having the same 3D stereo configuration, but opposite stereochemical designation. Right, so that's their relationship, or the interesting part of their relationship.